A buffer solution contains 0.55 molarity acetic acid, HAC, the Ka of which equals 1.8 times 10 to the negative 5, and it contains 0.45 molarity sodium acetate, NaAC. Calculate the pH of the solution. Calculate the pH of this buffer. Well, guess what? We already did this problem. We just did it a minute ago when we did the hydrofluoric acid and the sodium fluoride. We called it the common ion effect. Well, this is it. We have a common ion, the acetate ion. We have acetic acid, sodium acetate. We have a common ion situation. We have a buffer solution. Let's see what's going on here. What's the first thing that we do? We check the major species in solution so that we can decide what the major chemistry is going to be. There's always going to be something, one or two species that are going to dominate. We have our acetic acid. Acetic acid is a weak acid. This Ka tells us so. That means mostly it's going to be HAC. It is not going to have dissociated completely. We have H2O. We've dropped all of this in water. We have sodium acetate. Sodium acetate is a fully soluble salt. It is floating around as free sodium and free AC minus. Of these solutions, an equilibrium, the dominant equilibrium, is going to involve this species and that species. And here's what the equilibrium is going to be. HAC in equilibrium with H plus AC minus. Now we'll do an initial, a change, and an equilibrium. Our initial HAC concentration is 0.55 molar. 0.55 molarity. 0 here. Our initial acetate concentration is 0.45 molar. Sodium acetate, fully soluble. It dissolves completely, right? Just to show you, NaAC dissolves completely to Na plus AC minus. That's what this is right here. Therefore, 0.45 moles per liter produces 0.45 moles per liter of acetate. 0.45 molarity. Well, some of this is going to dissociate. Some of this is going to show up. Some of this is going to show up. 0.55 minus X. This is X. This is 0.45 plus X. Now we set it equal to the Ka. Our Ka is 1.8 times 10 to the negative 5. It's equal to the hydrogen ion concentration X times the acetate concentration, which is 0.45 plus X, divided by the HAC concentration, which is 0.55 minus X. Again, we're just numbers. This is probably going to be pretty small. X is pretty small compared to the 0.55 and the 0.45, so it's a reasonable approximation to go X times 0.45 divided by 0.55. When we solve for this, we get a hydrogen ion concentration of 2.2 times 10 to the negative 5, which implies that the pH is equal to 4.66. There we go. You have a buffer solution. You have a weak acid, acetic acid, and you have the salt, a salt of its conjugate base. The conjugate base of acetic acid is acetate. A salt containing that is sodium acetate. When you drop all of these in solution, the things that are floating around are the acid, not the free ions. The acid itself is weak. That's what this Ka says. It's not dissociated. Water, free sodium ion, free acetate ion. There is an equilibrium that exists among the acetic acid and the acetate and the hydrogen ion. It has a Ka. There's a constant associated with that equilibrium. It's equal to 1.8 times 10 to the negative 5. We can use all of these numbers to establish, to find what the hydrogen ion concentration is under these circumstances. And we end up with 2.2 times 10 to the negative 5 moles of hydrogen ion in 1 liter of this solution, moles per liter, which gives us a pH of 4.66. Okay.